So the first main string pulls on the axle in the back, which spins the wheels. You tighten it up, and the weight will go up. And our second string comes out through the toe, goes down, and attaches to our mousetrap. So as the weight slowly gets pulled down, the string slowly becomes more and more taut. When it hits the finally bottom section, we know that we're at 10 feet, and it then triggers our little sugar threads. So the three things that our group decided to use were wheel and axle, most obvious, obviously. So we have in-kind planes that we have a little bit of an arc when we actually shoot. And up inside here, we have a pulley. This pulley was also used to reduce friction. So when the string was going up, it wouldn't be rubbing against this wooden dowel. As we found, when it did that, it created too much friction, and therefore it would not actually start moving. So we chose Speedies for wheels. They seemed pretty good. We didn't decide to put a track on them because we had a lot of weight to make so we had traction on the floor. We have our tower design on the main section of it to be able to hold the string and have it wrap around properly in the middle. So we have enough string to go forward. That's pretty much it.
Less than 120 pounds?
Yeah. 30 by 30 by what millimeters? When you were building it, what problems did you have to overcome? What were some of the difficulties?
Our wheels were our biggest problem. We actually had a little rubber band around all of them.
Any other questions about what they encountered?
Let's see it go.
Okay. All right. Yeah.
We're hungry.
Anyone else just see that?
What? The gotcha.
Okay, what we'll do is we'll go around through this once. If anybody misses for some reason, you can get another chance or two. But we want to go through all the groups first. So we'll have one run, whether it's successful or not, and then you can make some minor adjustments if you want and make another run.
You ready?
Ready? Music. Okay. What went wrong, do you think?
We originally started out with a big giant box that we were going to fill with balloons and it was going to triple the film, but that didn't turn out. It didn't work out. So what happens is we have this string which is connected to our axle, which is on a mousetrap, and it pulls it forward, and this dowel gives it torque. So it's not just an immediate snap, it goes slowly. And once it's done, it hits the mousetrap and sends it off after 10 feet. So our three basic symbols is the machines. We have wheel and axle. We have a lever. We have a lever. The pulley. Pulley. Yeah, the pulley and the flat plate. And that's the Goliath.
All right. Were there any problems when you constructed this? Were there any difficulties that you had to kind of overcome?
Yeah, at first it wouldn't launch, and that's when we realized that we needed a wider spool or more torque to actually make it work. And it would move like 2 inches, and then we'd tap it, and then it would go.
Okay. So how did you overcome that?
We put these axles in, and we put graphite in there to reduce friction.
Reduce friction.
And we also grate them.
Okay. All right.
And our base crashed, but we fixed it with a pencil, so it's not good. That's when some teams doesn't have.
Did you have to do any calculations to determine how to make it go 10 feet? What did you have to consider?
Battery?
Trial and error.
Trial and error. Okay. All right.
initially.
Fair enough.
To drop 8 inches, but
We tried calculations, but then we just... Do what you want, sir.
One test is worth 100 calculations.
Yeah.
Hey, ready?
No, sorry.
Everyone, hey.
so the line is parallel to that.
Well, the line is
yeah.
center line 5 feet away, so you go right down the center line.
Right.
Oh, but
He's got the drum. Beautiful.
is there a way of... Tell us how it works.
So our unit, we have
rubber band on the bottom that you spin up and then straighten up, and then when you let go, it's in the axle in the door. And then our shooter is tennis ball, and this on the other axle is the shooter is the mouse trap. The shooter is attached to the other axle, and which winds up the rope. So when we get to the 10 feet, it will launch the... Hopefully launch the rope.
And I noticed you have is that a bottle of shot there, or is there...
Yeah, add weight.
Add weight.
The rubber bands like move the axle so fast that there's no weight on there, there's no friction.
Gotcha. Okay.
And our 3 simple machines are lever ones with the mouse trap, and then we have a series of pulleys are around the axles to make it move, and then obviously
Wheel and axle. Okay. Good. Are there any problems that you encountered when you did this? What did you have to overcome?
Well, first, our rubber bands that broke. So
Okay.
we went through a series of rubber bands trying to figure out which ones we could take and become 10 feet.
Uh-huh.
And then also our shooter, we had trouble with 8 feet.
Okay. All right.
Yes?
How many rolls of tape did you use?
I'm going to say about 20.
What kind is it, duct tape?
Duct tape.
It's the duct tape
Any
band?
kind of tape you can imagine.
Are those the rubber bands from...
Yes, yes. Second.
Okay. Nicely done. Okay.
Sometimes I've been touching garbage out.
Extra points. Is it wound up now? Okay.
Where's the rubber?
Yeah.
Actually, the way we wind it up is we track off the 10 feet, so we know that when rubber bands are released, they'll go to 10 feet.
Okay. I noticed you have some tape on the rear wheels
Yeah, that was also for friction.
for friction. Okay.
You did lift it off the ground, so you know that. Okay.
Yeah. You get to the bottom yet?
They put in friction.
It's like chocolate. No. It is. It is. It is.
Well, let me
Wow.
I totally missed that one.
I don't know. Judging on speed, that would get it. Man, that is, huh?
We'll see you again.
Red flag, red flag, red flag.
I don't know, even if M1, whatever that tank is, I don't know, they could fire that fast.
It was right there.
That was slick.
It didn't, it couldn't pursue.
I want to see that again. We'll film it all again.
Yeah.
Let's lift it up here.
Here I have our binder, which has the collection of illustration and brainstorming that we went through the first 3 weeks.
Oh, no, there.
Like to pass this around. Flag for unsportsmanlike conduct. I do. Okay, tell us a little bit.
All right. So the propulsion works with a pulley, which is a I don't know what to call that. It's a metal rectangle filled with nuts and bolts, velcroed to a lock with a string tied around it, wrapped around this little spool, and the string goes down and wraps around the back axle. As the weight drops, it trips the mousetrap, which should be mounted up there. And the ball, which is nestled in the spoon up there, is launched at the target. So,
well, we have obviously the wheel and axle right there, and then the pulley.
no, I mean, that's
Go ahead.
And then we have the pulley, right? I can't point. And then,
You've broken it again. Oh, that could be bad.
and then, go on the look. And then,
To the rescue! Love him.
What was the third one?
I want him to be my little brother.
Okay, all right. What did you encounter as you were building this? What kind of problems did you encounter that you had to overcome?
Well, first we had to do a concept, so we went through, we were actually going to do piles from a band idea, but we kind of ruled that out. We actually had the idea of being propelled by balloons, to propellers, to actually having a plane that drops the ball in there. It's actually in the illustration. Another problem we encountered was friction. Originally, this thing didn't roll, so we scrapped CD wheels which were there, and we manufactured these wheels which are all exactly the same diameter and have holes right in the middle. And see, we put graphite lubrication on it. These axle blocks actually have polycarbonate inserts, so then it reduces the friction along with putting graphite inside of it.
How do you prevent those wheel discs from wobbling back and forth?
Well, they do a little bit, but
Yeah.
we make sure that the hole on the inside is either the same size or slightly smaller.
It's like press fit.
And also another problem was being able to adjust the angle of the mousetrap, because the chances of us catching it was pretty slim. So all this stuff down here is Velcro, so we can move it around.
I notice you have a piece of dowel that comes out of the front of that block.
That's what trips on the mousetrap.
Did you have any problem with torque on the axle? Or did you...
I don't think so.
No.
It comes down pretty steady.
Yeah. Okay.
Did we count that as a timeout?
I was going to say that for 5 minutes.
Did they give us a 2-minute warning?
Don't even talk about that. We think we're okay when you give us our timeout.
Oh, okay, give it a second to dry. I'd rather have you.
Can you put it on the ground? And you gotta do it in midair.
Do not shoot that. I will shoot you in the face with a gun. I don't care. Let's go. Oh yeah, that was real good.
I like the braking part.
I do too. Yeah, that's a pretty cool
I like
thing.
that.
Austin, you broke my hand when I tried to move it.
I believe they're open line.
We did.
You're a wee bit over the line.
It's like a mini Kyle.
He did.
Oh. Wow, they're rough.
I've been insulting you over here and you ain't even paying attention.
Wow. Yeah, they are the Jets. I like that. They're the Jets. Jets, they're the Patriots tonight.
Kidding me?
How much you going right now?
What are we doing in town?
Like 20 minutes ago?
Yeah.
Kyle, I said he was creating a mini tile and lining it up perfectly, like $4 grand. And Matt said you can't get much smaller.
So that mousetrap just sort of
Aw,
is
poor
just lying there?
Kyle.
Yeah, it's wedged in between the
Oh.
block behind it and this block.
Okay, all right.
We have Velcro.